Good morning. Today's topic is about the principle of superposition. In earlier classes, we have discussed about the charge and the force. That is, the force between two charges, 2 point charges, using Coulombs law. So, Coulombs law is applicable for 2 point charge system only. But if you have n number of charges, then we can use the principle called principle of superposition, because in a system we cannot restrict only for two charges. There is a chance of 1 to n numbers. So if you are having that situation, how will you determine the force due to multiple charges on one particular charge? So we are going to understand that. So first of all, you can just recollect the force formula with respect to two charge system by Coulombs law. So as we know that by Coulombs law, the force between the two charges can be given by an equation, that is F is equal to K Q1 Q2 by the distance, separation is R square, and we have discussed the range of a distance also. Okay, but here it may extend up to any level. So therefore, so you can imagine that what is this situation here we are going to consider means, here we are going to say there are n number of charges. We do not know how many is there. It's just to say that it is n number of charges. So it starts from Q1, Q2, Q1, Q2, Q3. It goes on up to the part of Qn. So if Q1 is the charge and Q2 is another charge and Q3 is another charge, which is in a system, if we are going to see, there are n number of charges located at different point, anywhere randomly, and they are separated by some position with respect to the different charges. So therefore we can say that R1 vector comma R2 vector, so the distance of separation R3 vector, it goes on up to Rn. So this is the position at which all these charges are located. Then we can write the equation with respect to these charges. What we can write means, as we know, the vector form of Coulombs law. What is the vector form of Coulombs law means? You can just write the equation as so for example, if I am going to write the equation for F1 vector, that is force on the first charge because of the other charges present around it. So therefore we can write F1 is equal to, we can write the equation as F12, meaning that force on first charge by second and force on first charge by third. So likewise it can be extended up to the n numbers. So therefore F1 n numbers, that is F1n. So this is the force on the first charge. So from this what you can infer means, you can just understand that it is the force due to any charge in a multiple system. Force due to any charge, that is force on any charge, is nothing but vector sum of, because we are summing up with the vector quantity. So therefore vector sum of individual charges like Q2, Q3 and Qn up to. So therefore up to Qn, if I am going to say they are going to execute some force on the first one, therefore vector sum of individual forces executed by individual charges. So therefore it is a vector sum of all the other forces, is nothing but force on the one charge. So this is what the definition for principle of superposition. So principle of superposition says that, what does you can say means, the force on one charge is nothing but vector sum of forces exerted by individual charges. And suppose if I am going to say there is a first charge and you have 2 and 3, then what you can say, 2 and 3 will be there, 5 and 6 will be there, they will be located at different point because n numbers are there. And the force between the two charges, according to Coulomb's principle, the force between the two charges like 2 and 3 or 5 and 6 example, anything. So this is not disturbed because of this first force. So the force on the one, that is force by the other forces exerted by the charges on 1 is not disturbed because of their internal forces. So therefore, force between two charges is not disturbed because of this force exerted by the other one. So therefore, you can also remember that point. That is, in addition to this, you can also remember that force is not disturbed between two charges. So force between two charges is not affected because of this behavior of principle of superposition. So once again, I will just tell what is principle of superposition means. It is nothing but force on one particular charge is nothing but vector sum of forces exerted by all other individual charges. You can also remember that all other individual charges, because up to n numbers you can just apply all other individual charges. That is what F1 vector is equal to F12 vector plus F13 vector plus up to F1 n vector. Okay, so this is for n number of charges. So now, to understand still better, we will have a situation that there are only 3 charges, because principle of superposition is applied for the charges which is more than 2. Because if you have 2 charges, then you can use Coulombs law. If it is more than 2, then you can use a principle of superposition. So using principle of superposition, we will consider there are 3 charges allocated, Q1, Q2 and Q3. In a system, we just imagine there are only 3 charges. So for this, to understand the vector positions, we will make a coordinating axes, that is x and y. This is x coordinate and y coordinate to indicate the position of 3 charges. Okay, imagine that one of the charges, that is one of the charge Q1 is located at somewhere from the origin at the position of R1 vector. R1 vector. Same way, here we can imagine another point. This is another point at which the second charge is located. Imagine another one point where Q3 is also, just Q3 is located here. Okay, so we know that Q1 and Q2 and Q3 are the 3 different charges located with a different location, and I just marked the location or the position of charge 1 with respect to that origin. It is of R1 distance. Same way, I can just mark the position for other 2 also, as this is R3 vector, and even this can be as marked as this is R2 vector. So R1 vector, R2 vector and R3 vector respectively for the individual charges. Okay, and now we can just understand this charge 1 will get a force exertion from the second charge, also from the third charge. Same way, other 2 also will experience a force from the other 2. If I am going to consider 2, then 1 and 3 will exert force. If I consider 3, 1 and 2 will exert force. So we will consider one case alone now. So therefore, we can explain the equation how it is going to. Okay. So now, what is the equation you will get? Because see here, you can say Q1 and Q2 will experience some force because of their distance of separation. What is the distance of separation? We know that position is R2 and R1. So therefore, with respect to R2 and R1, we know that the force exerted by the second charge on this one, we can write it as R21 vector. R21 vector, and the force is acted upon in this way. Therefore, the force on 1 by 2. This is the direction of the second charge, making it on first one. And same way, here we can say that the Q3 charge is also going to exert some force. Therefore, I can just mark this is R31, because R31 vector is from 3 to 1. Therefore, the force is exerted in this way. So the force here it is F13, that is force on 1 by 3. So with respect to the resultant of F1 and F12 and F13, the resultant would be somewhere in between here. So therefore, this is what F1 vector. So that is what the force experienced by the charge 1 because of the 2 and 3. So this is a vector notation, and so therefore with respect to the positions you can just make a equation. So how will you make a equation means you can just imagine F1 2, that's what the first one, F1 2 vector. So F1 2 vector according to Coulombs Law vector form equation you can just write 1 by 4 pi epsilon naught Q1 Q2 by the distance, that is we can just r cube because I am writing in vector form. So F12 means it's the position is R21, so therefore R21 vector. So this is for F12. And what about the case of F13 vector means it is 1 by 4 pi epsilon naught of Q1 Q3 by R cube R31 vector. So right from the vector form we just written this, and what is the total force F1 means? F1 is nothing but vector sum of these two. So therefore F12 vector and plus F13 vector. So just we can have the common terms outside, therefore we can write Q1 divided by 4 pi epsilon naught inside the bracket, Q2 by R cube R21 vector plus Q3 divided by R cube R31 vector. So this is the equation. Suppose if I am going to say there are n number of charges. So if it is from 1 to n, then how will you make a equation means? It's very simple. So here we can get an equation for 3 charges. So for n number of charges you can just make a equation as F1 vector is equal to Q by 4 pi epsilon naught summation of I is equal to 2 to n, because the first one is Q1 and second, from second charge only we are starting it, so therefore summation of Qi, because you will substitute this value as 2, I equal to 2, and the denominator is R cube only, and what about this 2 here, that is Ri1 vector, Ri1 vector. So for case number 1 we can substitute I equal to 2, that is Q2, and I equal to 2, that is R21 vector. Same way if you put 3, then Q3 by R cube of R31. So it goes on up to n numbers. So for if you are going to have n number of systems, then you can use this idea. This is for force on the one charge. If I am going to have multiple charges, then this same equation can be expanded in applying the different values of the different charges. So therefore we will get an equation of force, that is using principle of superposition. So here in this class we have understood that what is principle of superposition and when this principle of superposition can be applied. So principle of superposition can be applied when you are going to have a more than 2 charges. That is, if 2 charges are there, a force can be calculated by Coulombs law. If you are having more than 2, then you can use principle of superposition. Here we have taken an example, that is with respect to 3 charge system, the equation is created. For if it is about for an n number of charges, then you can use that with a mathematical equation, that is I equal to 2 to n, then you can change the equation, therefore you will get a force on the first charge. Okay, so this is about principle of superposition. Thank you.